Okay, let's talk about determining scale. Uh, Scale isn't solely something that is given to you. Sometimes you have to determine the scale based upon the constraints that you are working with for the problem. For example, the table shows the distance between the Sun and 8 planets in our solar system. Mercury at 35 million miles away, Venus at 67 million miles away, Earth at 93 million miles away from the Sun, Mars at 142 miles away from the Sun, Jupiter at 484 million miles away from the Sun, Saturn at 887 million miles away from the Sun, Uranus at 1784 million miles away from the Sun, and Neptune at 2795 million miles away from the Sun. So if we wanted to create a scale model of the solar system that could fit somewhere in your school, what scale would you use? So, for example, this problem, we might be trying to fit our solar system onto a piece of paper, or you might be trying to fit it onto a wall in a rather large room. So let's take a look at that. All right. So let's say for our problem, we have a wall of 100 feet in length where we can place our solar system. For better visualization, I have drawn a line of 10 inches in length so that each inch can represent 10 feet on the wall. But that is my scale for this explanation, not for the placement of the solar system. When it comes to determining our scale for the solar system, we need to look at what is the longest distance needing to be depicted. Thus, Neptune, at a distance of 2,795 million miles, is the furthest away from the Sun. Now, let's clarify things. Oh, I hate that one pops in the way. Let's clarify things. So, you don't want to read the chart incorrectly. We have Mercury at 35 million miles away. So, let me just write it out the long way. 35, and then 000. That's 35 million miles. That's Neptune. We're talking 2,795 million miles away. We'll put that on front of our 000. So it makes it easier to see that Neptune is nearly 3 billion miles from the Sun. Nearly 3 billion miles from the Sun. So, if that's the case, well, we have 100 feet and on our wall, and we have to divide that into the 3 billion. And so we come up with 30 million miles. So 1 foot represents 30 million miles. And so if we think about it here, right? We got the Sun, and we got Mercury, we got Venus, we got Earth. Because remember, if we think about what was going on before, right? Earth is only 93 million miles away. So technically, it's only about 3 feet away. 3 feet away. And so if I have my 1 inch equaling, 10 feet, we see how closely these things are relating here, right? And how it spreads out there. And that'd be roughly the same way here. So 1 foot represents 30 million miles. Fortunately, we dropped planet status for Pluto. Otherwise, I don't think I could put Mars and the Sun through Mars all together on one paper. All right, let's talk about that next question there. Okay, the diameter of Earth is approximately 8,000 miles. What would the diameter of Earth be in your scale model? Well, let's think about what we know about ratios. We've got 30 million miles to 1 foot. Well, 30 million divided by 8,000 is 3,750. So if we divide the top by 3,750, the bottom by 3,750, we'd figure out that we got about 2 10,000ths or 3 10,000ths of a foot, which is roughly 3 thousandths of an inch. Which, if we talk about this, we're talking about something which is smaller than a fine grain of sand. So actually, if I were to put it on my paper here, you wouldn't be able to see the dot. So that's just food for your mindset there. All right, let me get out of here. I'm running out of time.